Now let's pretend that a user is on a computer using an application that communicates through the wire to another computer, and they want to send a message that contains text, maybe contains pictures, might even contain sounds, and that message is going to go from one computer to the other computer. Well, to the user who is using the application, it seems like the message just goes from one computer to the other computer. But what actually happens is that message goes through several transformations. The information that's contained in the message goes through several transformations. So as the data is prepared by the computer to be sent over the wire, the computer has to create a system so that the computer on the other side can interpret the information. And so there are several different layers that message will go through before it actually ends up on the other side. And those layers of the OSI model are very important. Now, one thing I want you to notice is that the layers are numbered from the top down, with layer 7 at the top and then 6, 5, 4, 3, 2, 1 as we work our way down. Now what we're going to do is we're going to start off, and let's pretend you are a packet and you are going to be sent through the system. In other words, you are that message. And the first thing that has to happen as it comes out of the application layer, which is where the user actually is, and when we talk about applications we'll get more specific later on, but we're not talking about Office type of applications. We're not talking about Word and Excel and PowerPoint, those type of applications. What we're talking about are communication applications. Well, let's say they're sending a file. It's file transfer protocol. They're sending a file that has some text and some pictures and even some sounds in it. Well, what has to happen is we start off at the application layer, then we move to the presentation layer. At the presentation layer, each packet is coded so that it can be determined on the other side what kind of packet this is. In other words, is it going to be interpreted as text, or is it going to be interpreted as a picture, or is it going to be interpreted as part of a sound? Is it going to be interpreted as just a color? So at the presentation layer, what you should remember is that there is coding going on the way down. On the way up, it'll be decoded, but it's coding. If there's any compression that's necessary because of the protocols that we're using, then the compression takes place. Good thing to remember about the presentation layer is it's a translation layer. It's being translated into something that the computer now understands, but the human probably wouldn't understand. At the session layer, the next layer down, the session protocols that allow the two computers to communicate in the first place are being set up. The protocols that allow the communication to start, to initialize, and the protocols that will eventually allow the communication to terminate are set at the session layer. At the transport layer, the information is actually being put into packet size form. And each packet is being addressed in such a way that it can be guaranteed for delivery through the network, or that it can be just blasted out into the network and not guaranteed for delivery. In other words, we've got both types of protocols at the transport layer. Those that require an acknowledgement and therefore give us some guaranteed delivery, give us some assurance that the packet is going to be delivered or it's going to be duplicated. Or we can have broadcast type of packets that are just going to go out onto the network. But at the transport layer, that's where the packetization of that information, it's being broken down into smaller parts so that it can be sent over the network. Which brings us to layer 3, the network layer. The network layer is responsible for the addressing. The addressing mechanisms are at the network layer. At the network layer, we use IP addressing. We could also use other types of addresses, like IPX addresses. So at the network layer, this is where the routing takes place in a network, because that's where the network information is that would allow that to happen. At the data link layer, we are still working with addressing, but we're working with physical addressing. At the data link layer, we're working with the MAC addresses that are burned into network interface cards and that are assigned to router interfaces throughout a network, the physical addressing in the system. And then finally, at the physical layer is where we define all of the physical characteristics, the electrical characteristics. For example, if it's a network interface card, well, how many pins does it have? What voltage does it run off of? If it's a cable, how many twists does it have to have? So it defines all the electrical and physical characteristics through the network. Then all that happens is on the other side, all the information that has been coded through this side is then decoded. Every piece is looked at. And so as the information works its way back up towards the computer on the other side, all that information is read at each level. So that what ends up happening is that if you were to draw a line at any point in the model, you would see that the packet looks about the same, or looks exactly the same as it did on the other side. In other words, all the information that was added that coming down this way has now been taken off, and so if you were to draw a line, it would look the same. And that's why it looks the same at the application layer. And speaking of the application layer, that's what we'll start off with. We'll get into more specifics about the application layer next.